Did you know that there are over 1 billion sheep in the world? Or how about that sheep have a 300-degree vision, being able to see in front of them and behind them at the same time? Well, did you know that in 1996, Dolly the sheep was created? She is the first mammal to ever be cloned from a somatic cell. By the end of my speech, my audience will be able to have more knowledge about Dolly the sheep's creation, the safety to animals through animal cloning, and what has been happening since Dolly's passing. Many of you might not know of the importance and achievements brought to humanity through the cloning of animals. But cloning has been a topic debated with scientists and world leaders throughout our entire being and our existence. It's a very important topic. A clone is an organism that has the same DNA makeup as its parents, therefore making them genetically identical. I'm here to introduce you to Dolly the sheep, who was a part of a major scientific feat by being the first mammal to be cloned from an adult cell. So Dolly is not your usual sheep, as you already know. So let me tell you a little bit more about her. Animal cloning has been experimented and conducted many times before Dolly, but never from an adult cell. The cloning process is usually done through the embryonic cells. Those cells divide much more quickly than any other cell. The scientists who conducted this study at the Roslin Institute of Scotland needed 277 attempts to finally create Dolly. You can read more about this at animalresearch.info website. Dolly was created from udder cells from a Finn Dorset white sheep. The scientists had to experiment ways to reprogram the udder cells to cancel the growth while also keeping those cells alive. Shockingly, they accomplished this feat and injected the cells into the mother sheep, which then it was fertilized and then produced Dolly. After the cells fused together in the mother's body, they were cultured for 7 days. This helped within the research, and it helped techniques for further advancements, which I'll tell you later on. Dolly's creation and beginning was very complicated, but now we can talk about the rest of her story. 277 cell fusions, 29 embryos, 13 different mothers, and 1 full-term pregnancy. Dolly was born after 148 days. Dolly lived within the Roslin Institute in Scotland, and there she produced offspring normally. She lived 6 years before being euthanized because of arthritis and pulmonary adenomyosis, which is lung tumors. This is actually Dolly stuffed at the Roslin Institute. Dolly had a few health problems, though, near the end of her life, which brings me to the frequent concern of animal cloning posing safety issues to the animal and the animal products. Cloning debates have a focus of safety to the animal and what the animal produces. The process of cloning the cells themselves does not pose any initial risk or threat to the animal, but unfortunately, the actual cloning has been met with late abortions, immune system failures, circulatory, respiratory, and high rate of fetal deaths. What I just told you about was concluded from the research of Dr. Frank Ipdisham with the Russian Journal of Genetics published in 2017. Only a small percentage of cloned animals actually have live births. So, cloned animals born outside of the veterinary care have little chance of survival. Survivors suffer from a wide variety of diseases, defects, so they're usually kept in the veterinary care to be watched over and to be researched on throughout their lives. Consumer safety is the next but majorly important characteristic of cloning. The Federal Drug Administration concluded that offspring of cloned animals is safe for human consumption. Food labels do not have to say that the food is from a cloned animal or from the lineage of cloned animals. But the FDA does recommend that other than cows, pigs, goats, and sheep. Animals other than that, you probably should keep out of the human food supply. So, what has been happening since Dolly's passing, you might ask? Let me bring you up to date with the help of the website animalresearch.info. Dolly's creation and passing has spurred the setup of many other cloned animals and animal projects. This includes sheep, cats, horses, dogs, cows, almost anything you can think of. But that's just a short list. In 2014, a mouse was cloned from a nucleus olfactory neuron. This was important because now we are starting to clone undividing cells. So you take a brain cell and they're starting to be able to clone those. It's very important to science. So Dolly's cloning technique has now been improved, creating the cloning of animals to become cheaper and more reliable. Which, easy on the cheaper, but it still comes with about $100,000 sale tag on it, so you can only imagine what it was before then. So finally, because of Dolly's advancements that have been made to cloning, we've been led to a potentially new therapy for mitochondrial diseases in humans. This graph here explains a little bit more about it. But mitochondrial diseases are passed on through the birthing process from mother to baby, and it's one of the main causes for muscular dystrophy, as we all know, is a debilitating and sad disease. But 1 in 6,000 people are born with this defect, and without the potentially new therapy invention, the disease will be passed on to generations without any like there's no slowing it down through this. But with some of the cloning projects that we're working on, we can actually clone and get rid of the mitochondrial defect and then pass it on through generations without the defect. So, during this speech, I've introduced you to Dolly the sheep, the safety concerns through animal cloning and cloned animal products, and contributions to the cloning process and human advancements. Dolly will be added to a great group of animals that have entertained us and really helped our world advance in spectacular ways. So this group includes Ham, the monkey that was sent to space, Jonathan, the tortoise, who turns 180 this year, and Pennsatucky Phil, the groundhog that can predict the weather. Thank you.